It's one of humanity's most ambitious projects, a wall of concrete so massive it could pave a 2-lane road from New York to Oklahoma City. And it was built to tame the river that carved the Grand Canyon itself. But today, this engineering marvel faces a crisis. Lake Mead, the largest reservoir in America, is disappearing, and the consequences could be predictable. In 1905, it broke through its banks, flooding the Imperial Valley and swallowing entire communities, farms, homes, entire groups of people, all gone. But flooding was only one issue. The nearby cities were expanding, farmers needed reliable irrigation, and everybody wanted electricity. The Colorado River could provide all of this, if someone could figure out how to control it. For hope, thousands of workers flocked to the Nevada desert, and at its peak in 1934, the project employed over 5,100 people. Boulder City had to be built just to house the workers. There were strict rules: no gambling, no alcohol, and no troublemakers. About $1 billion in today's money. The plan was to build the dam 221 meters tall, higher than any other in the world at the time. And the reservoir it created, Lake Mead, would become the largest artificial lake on the Earth, capable of storing up to 38 cubic kilometers of water, enough to supply 90 million American homes for a whole year. With 10 times more concrete than the Empire State Building and the most powerful hydroelectric plant in the world, nothing like it had ever been attempted before. All of that weight. Well, they found it in Black Canyon, with its sheer cliffs of volcanic rock rising hundreds of meters high. But building a straight wall across the canyon wouldn't work. The pressure from millions of liters of water would eventually crack the concrete and maybe even topple the entire structure. Instead, engineers designed a curved wall. The shape meant that the force of the water got distributed along the arch and into the canyon itself, rather than concentrating in on one spot. Think about an arched stone bridge. The curve of the bridge transfers weight to the pillars on either side. Well, the Hoover Dam works pretty much the same way. The walls create a structure that's naturally stable. The more the Colorado River pushes against the dam, the more securely the dam is held in place. The Hoover Dam is thicker at the bottom than at the top. At its base, it's as wide as 3 soccer fields, which gives it a low center of gravity, like a pyramid. But that massive base created another problem, because when concrete hardens, it generates intense heat. If the engineers poured it all at once, the dam would have cracked from the inside out. The solution was to construct the dam in individual blocks, each containing cooling pipes carrying water. After each block cooled, workers filled the pipes with concrete before proceeding to the next section. The technique worked well, and some of the concrete is still curing up to this day. Yeah, the dam actually keeps getting stronger today. The engineers also had to think about what would happen underneath the dam. Water under pressure can force its way through tiny cracks in the rock, eventually destabilizing entire structures. So they designed a network of tunnels and galleries inside the dam itself, which collect any water that seeps through, relieving the dynamite to blast through the canyon walls, creating over 5 kilometers of diversions to carry the river around the construction site. This was, unsurprisingly, dangerous work. In the tunnels, carbon monoxide from the explosions could be fatal. And high above the canyon floor, workers called high scalers dangled from ropes, clearing loose rock with jackhammers. One wrong move meant certain death. And for many, that's sadly exactly what happened. By the time the dam was finished, 96 men had lost their lives. Perhaps the most tragic story belonged to the Tierney family. J.G. Tierney drowned while surveying the river in 1922. Then 13 years later, literally to the day, his son Patrick fell from an intake tower, becoming the project's final casualty. To make the tunnel work more efficient, engineers developed the Jumbo Rig, a steel platform carrying 30 drills at once, powered by compressed air. They used it to bore holes into the rock face for the dynamite. After each explosion, workers would clear the debris, check for any hanging rocks, and start the whole process over again. A key phase came when they had to seal off the river itself. They dumped thousands of tons of rock into the river until the water diverted into the tunnels. As the river flowed around them, the engineers built temporary dams called coffer dams at both ends of the construction site. This created a They had to dig down 40 meters, about the height of a 12-story building, before they hit solid bedrock. The canyon walls also needed to be completely cleared, as any weak spots could compromise the structure. And then came the concrete work. To help with this, the engineers constructed a system of aerial cableways across the canyon. These transported buckets, each holding 6 cubic meters of concrete, to specific positions throughout the construction site. Inside the dam, 4 intake towers were built to feed water to the power plant below. The water would travel down through pipes large enough for a truck to pass through, each one 152 meters long. When the dam became operational, these pipes began feeding 17 turbines, generating enough electricity to power 1.3 million homes. Yeah, the scale on this thing is insane. But how does the Hoover Dam actually work? Well, it has 2 main functions: generating electricity and controlling the Colorado River. For flood protection, engineers built spillways on either side of the dam. Each one can handle almost water downstream when Lake Mead gets too full. They're basically an insurance policy. In the dam's entire history, they've only been used 2 times. Once in 1941 for testing, and again in 1983 during major floods. The dam can also release water in a more controlled way through its outlet works, basically giant valves that can be opened or closed as needed. This system irrigates over 1.5 million acres of farmland, turning parts of the desert into some of America's most productive agricultural regions. It allows farmers to grow water-intensive environment. As we mentioned, when the Hoover Dam was first built, Lake Mead became the largest reservoir in America, deep enough to cover the whole of Pennsylvania in 30 centimeters of water. Within 6 years, the landscape had transformed. Cities like Las Vegas, Phoenix, and Los Angeles expanded beyond what the natural water supply would have supported. But it came at a cost. Beneath the lake, ancient wildlife habitats vanished overnight. The Colorado River was forever changed. Its natural flow, the seasonal floods and droughts that local species had evolved with, was now controlled water. But on the flip side, the reservoir created new ecosystems of its own. Fish species adapted to the lake environment, new wetlands formed along its shores, and plenty of animals now depend on it. Plus, it's a recreation destination for sets of homes. The situation has become so serious that both Arizona and Nevada have been forced to cut their water usage. As you might expect, climate change is at least partly to blame. The Colorado River Basin has been experiencing a water supply even if the water level drops. Meanwhile, Arizona is experimenting with water banking. It's currently stored over 4.5 cubic kilometers of water held back. But what do you think about the future